Executive Academy. I am SMD and I represent SMD Executive Academy, an institution dedicated to recognizing and cultivating the sharpest mind in academia. Today, what we bring to you today is still on quadratic functions. But this time around, we're going into graphs of quadratic equations, or we can say the graphs of quadratic function. In this case, do we necessarily need to draw the graph before we can talk about the properties of quadratic graph? No, this is the way it goes. Without completely solving or without completely graphing your equation, you can tell properties of the quadratic functions even without graphing it at all. Now, first, let's talk about the properties. What are the properties of a quadratic graph? Number one, let's just take an example of this. Okay, let me just begin by saying that the graph of a quadratic function has to look. When you want to draw, most of the time, the kind of question the teachers must have given you before is usually a U-shaped quadratic equation, because no teacher would want to stress you, or definitely if that teacher would want to stress you, we give you a kind of quadratic graph that is negative, so it's going to give you an N shape. But most of the one you must have seen before or come across should always be a U shape, and this is the reason. Now, for the first condition says that, let's see, what is the format of our quadratic equation? The format is always ax squared plus bx plus c. So this is the lookalike, or we can say that the format of a quadratic function. A stands as the coefficient of x squared, b stands as the coefficient of x, and c is the constant. That is we can say that the value of kind of the variable is not showing, but it's there, so we call it constant, because the variable of this c as the variable of x raised to power 0, which is 1, because the power of x is decreasing by 1, so it decreases from here to here by 1, from here to here by 1, so this x will not show. So let's just call this one a constant. Now, having known that it is a constant, now how the graph of a quadratic function looks like. So the first condition is if the quadratic equation, if your a is greater than 0. That is, you notice that whenever the question comes to you, your coefficient of x squared, which is a, is usually greater than 0. Then this is the look you will have when you draw that graph. You have this look. So let me just plot it like a kind of a graph like this. So this is my y-axis, that's my positive y, this is my negative y, this is my positive x, this is my negative x. So when you draw a graph that has a question, like that has the coefficient of x squared greater than 0, that graph, that question will give you a graph that is giving you a letter U shape. So this is going to give you a letter U shape. But what are the things we can talk about this property, the properties of this quadratic graph? The first thing we need to know is that this U shape has cut 2 points on the x-axis. It's cutting 2 points on it. So it's cutting this point here, and it's cutting this point here. So we can say that at these points here, this is our x-intercept. So we can say that at these points, you have the first value of your x. You know, normally when you solve a quadratic function, you're meant to have two answers. So the first answer is going to be this, and the second answer is going to be this. That's the first 2 points there. So you have your x1, you can have your x2 here when y is 0, when y is 0. That's the first thing. The second thing we can pinpoint here is that whenever a is greater than 0, it means your graph will be a U-shaped graph. Then you will have a minimum value of y. So you have y minimum. Let me come again with that. If your quadratic equation gives you, if a teacher gives you a question and your quadratic function is having a greater than 0, you can detect that by yourself by looking here. So by a, if your a is greater than 0, take note of this. Number one, your graph will be giving you a letter U shape. That's number one. Number two, you're going to be having a minimum point because your graph, since it's letter U, is going to be sitting down. So it's going to be shooting at the bottom. So at this point, if you can locate the value of y, we can pinpoint the value of y here. Whatever value of y here is called y minimum. That's y minimum. Then also we can have the line of symmetry. We can talk about the line of symmetry. What does the word symmetry mean? When you hear the word symmetry, Symmetry is kind of a word that means that you're trying to cut something into two equal parts. That's the meaning of symmetry. So if you look at this graph, if our graph looks like this, then where is our line of symmetry? Okay, let me just say that I have it like this, so that we can say, okay, we can obviously see that our line of symmetry is not in line with that y. So if I'm having it like this, let's say my y-axis happens to be here. Let's have my y-axis this way. So I think it should be better this way now. So if I have my graph this way, then you can see that it's shooting at the bottom. So let's carefully look at the graph, the way it shoots downward. So at this point here, if I trace it this way, I'm going to have what I call my y minimum. So two things are needed to be observed. Number one, take note of when your a is greater than 0, it means that your graph will give you a letter U shape. It means that you will have a minimum value of y. Now, if you're asked to find the line of symmetry is usually on x-axis. So it means that if I need to divide this U-shaped graph into two equal parts, so it means I'll be cutting it like this. So I'll have to center here at this point, then kind of rule it up this way. I'm going to dash it up. So whatever value it gives me here is called my line of symmetry. So at this point, maybe probably if this happens to be 2, so I can say that for me to divide this graph into two equal parts, the value which I'm going to look into is x. So x equals 2. Then I put my ruler, I draw the line of symmetry this way. So which means that this line of symmetry means it is the line that divides the graph into two equal parts, and is usually on x-axis. I think we can get that now. So all these parameters or all these kind of properties we've been talking about, can we get it without without drawing the graph at all? Definitely we can do that. Number one, if I'm to get my line of symmetry, note that your line of symmetry is x equals to, your line of symmetry is x equals to, okay, let's take it this way. Note that your line of symmetry x is equals to minus b over 2a. So without you drawing the graph at all, if you can locate, if you can know what your b is and what your a is, without drawing the graph, you can know your line of symmetry. Sometimes we call it the equation of symmetry or line of symmetry. Find that there's no problem with that. So our x is going to be equals to minus b over 2a. And our minimum point, can we also get our minimum point without drawing the graph? Yes, we can do that. So note that your y minimum will be equals to 4ac minus b squared all over 4a. So you can use this formula here without drawing your graph. Let's say there is a question in the objective that says that find a minimum point of a kind of a quadratic function. Then you necessarily need to draw the graph, locating your minimum point, your line of symmetry. So my line of symmetry from the equation, I can just see x equals to minus b over 2a, and also y minimum is 4ac minus b squared over 4a. Now at this point, you know, it is only this one point we have used to detect our line of symmetry and also our minimum point. And definitely we know that for every point there is a coordinate. Remember that. So at this point there is a coordinate of x and y. So if you locate it this way, it gives me my y minimum. So my y here will be my y minimum. Sometimes you'll be asked to find the vertex. So this point is the vertex. So those places where you call edge, like this board now, this point of this board is not edge. Like normally we call it edge, right? So this place is called the vertex. This place is called vertex. So this is what we call edge. This part is what we call edge. Then this is vertex. All those corners are vertex, not those places where you call edge previously. So this is a vertex, not edge. So at this vertex we have coordinate, one coordinate, and the coordinate is x and y. So necessarily we need to know that at this vertex, our coordinate of a vertex, if the coordinate of a vertex is the x stands as line of symmetry and y stands as y minimum for when a is greater than 0. That's the first aspect of that. Second aspect says that if a is less than 0, if a is less than 0, definitely it means that your graph is going to look this way. Your graph will look this way. So your graph will have an N shape like this. So what are the things we can need to get? Number one, we need to get the x here. So we can get x1 and x2. Those are the points where the graph intersects the x-axis. Then if you look at the graph very well, definitely we should have a maximum value for this. So for when a is less than 0, your y will be y maximum. So how do we get y maximum? There is a point here, just like the vertex we said here. There is a point here. So our point here will be y minimum, y minimum. Then if you bring it down this way, it's going to give you the line of symmetry that can divide, or the line of symmetry that divides the graph into two equal parts. And it's going to be pointing on x-axis, just like the way we pointed this one on x-axis. So when it points on x-axis, we say that's the line of symmetry. Then x for line of symmetry will be equals to minus b over 2a. So it has the same equation with this. But when you dictate, first you need to dictate that if your a was greater than 0 or less than 0 before you can determine whether it's going to be minimum or maximum. Then my y maximum remains 4ac minus b squared all over 4a. So this is the nature of the graph for you to dictate without solving. We know that whenever a is greater than 0, it cuts 2 points on the axis there. Then also we have the minimum point, and our line of symmetry is x equals to minus b over 2a. The same thing here. So definitely, or let me just say apparently we need to understand that the line of symmetry means a line that divides anything into two equal parts. But because we are doing a quadratic graph, so we can say that the line of symmetry in this graph is the line that divides our quadratic graph into two equal parts, which points on x-axis, not y. So at this point also we call it the vertex. That's the vertex. So the vertex of this point is also x comma y. There, do you understand now? So it gives us x comma y. Then our x remains our line of symmetry. Then our y here remains our y maximum, because that's the point where it is heading to. I think at the end of this class, we should be able to have covered some things that we did not really understand before. So in our next video, we'll be giving out questions and how we can dictate questions. And basically, we're going to solve questions using those formulas. Thanks for watching. If you are coming across this video for the first time, kindly like, share, and subscribe to my YouTube channel. Thank you very much.